Hi everyone, today we're going to be talking about the osteology of the human foot. The view that we'll be working on today will be known as the lateral view. It is the outside view of the human foot. I've quickly blocked in all of this so that we can spend a little more time talking about the details. But essentially, a great way to think of how to draw the human foot, and I've just done a quick example up here. This is how I started. I just do a quick wedge shape form, very similar to a doorstop. And then I added a small light rectangular shape to the back. This comprises in here the majority of the tarsal bones and the metatarsal bones and the phalange bones. This is the calcaneus, represents the calcaneus bone, which we see that sticks out here. So here we can see that we have the wedge shape in here, and that's how I began. And then I added this very lightly in the back. I added the calcaneus. And then you can just add, depending on the ankle can come this way, it can be straight up and down, it can be back this way. And it is known as, the ankle here is known as a synovial joint. And essentially the easiest way to think of how to remember what type of joint it is to think of it as a hinge joint, very much like you would open and close a door. It sits on a hinge and it goes back and forth. And that's an easy way to remember what type of joint is in our ankle. So again, this is a synovial joint. The synovial joint is made up of 3 bones. It is made up right here of the tibia, the bone from our lower leg. The outside bone here is our fibula. And it sits on this large bone right here, which is known as the talus. And this is one of the tarsal bones. So very quickly, we'll go over each of the bones. And then I'll spend a little time at the very end of this doing a time lapse where I'll shade this. But for now, we just want to go over the information. So again, I started with very lightly. At this point, you can no longer see the wedge shape. You can see maybe just a little reminiscent of it under here and a little bit of the rectangular shape underneath. But once I start adding into the form, it should all disappear. I want to make sure I keep all the underlying information as light as possible, and then quickly go from just a very simplified shape into actual articulation of the anatomical knowledge. So here, this is the tibia. This is the largest bone in our lower leg. This is the fibula. This is the little bone that sits on the outside, the lateral side of our leg. And this bony process here, which forms the outside of the ankle joint, is known as the lateral malleolus. If we could see to the other side on the inside, the little bone that would wrap around on the inside, the little protrusion there would be the medial malleolus. So this is the lateral malleolus, and that is part of the fibula, and that comprises the outside of the ankle. And remember, this is a synovial joint that is made up of the tibia, the fibula, and the talus. The talus is part of the foot, however, not necessarily part of the lower leg. So in our foot, we have 7 tarsal bones. This whole area in here, this entire section, these are the tarsal bones. One of the larger bones in here, probably the second largest, is the talus, and that has a rounded area that this rotates on like a hinge. And that's one of the most important parts to remember when drawing the foot and the ankle in particular. The other part that I feel is really important that most beginners usually get incorrectly, this is the calcaneus bone. If you're taking an anatomy and physiology class and you're learning the regions of the human body, this is known as the calcaneal region, but this particular bone is known as the calcaneus. It's important in that you have to remember that it always sticks out behind. Wherever the tibia and fibula come in, the calcaneus must go behind. That is where the soleus, the gastrocnemius connect to the Achilles tendon, and the Achilles tendon would come down and it would insert itself into here. So the origin of the muscle is up higher, but the soleus The Achilles tendon and the gastrocnemius, all of those, the Achilles tendon wraps down into here and connects back here. We'll do a little demonstration also of the muscles in a minute, and we'll be able to see how this comes down and connects, and then the skin obviously fits over that fold. So this is the talus, this is the calcaneus. This little cube-like shape that fits right in here, this is the cuboid bone. This little section from the talus that connects into these three bones, this is known as the navicular bone. And then these three bones are all the same, and their name varies depending on the placement. So these are the cuneiform bones, and there are three cuneiform bones. The one that sits on the inside of the foot is the medial cuneiform bone. The one that's in the middle here is the intermediate cuneiform bone. And this one here that is on the outside, just like this is the lateral view of the human foot, this is the lateral cuneiform bone, and it's the one that's closest to the outside of the foot. So again, we have 7 tarsals. We have the talus, navicular, we have the medial cuneiform bone, the intermediate cuneiform bone, the lateral cuneiform bone, and right in here is the cuboid bone. The largest of all the bones in the foot is the calcaneus, and then the one that comprises our ankle joint, which is known as the synovial joint, this is the talus bone, and the talus bone again is one of the 7 tarsal bones. After the tarsal bones, we have the metatarsals. And very much like in the hands, we have digit number 1. In our hands, the thumb would be digit number 1, the pointer finger would be digit number 2, middle finger digit number 3, ring finger digit number 4, and the pinky would be digit number 5. We have the same makeup here in the human foot. So this would be very much like our thumb, except in humans, we don't have an opposable big toe. If we were one of the greater apes, this would be an opposable big toe. That's one of the big differences between humans and the greater apes. That's we no longer have use for an opposable big toe. So this is digit number 1. This would be the equivalent here of our pointer finger, and on most people, this is actually the longest toe of the toes in our feet. And this is digit number 2. This would be the equivalent of our ring finger. This is our toe, digit number 3. Then we have digit number 4. And then this would be the equivalent of our pinky, which also turns in and tucks itself into the side. And this is digit number 5. So very similar to the human hand. One of the main differences, again, we have 8 carpals in our hand. We only have 7 tarsals in our feet. And a somewhat interesting side note is that the majority of the bones, and it's generally believed it's an approximation, it's not true of everybody, but it's generally believed we have somewhere around 206 bones in an adult human being. We will have the majority of those of which are in our hands and in our feet. So we have, right in here, we have 7 tarsals. We have 5 metatarsals, and then we have 14 phalanges in our toes. So just like our thumb, the one that's closest to us is the proximal phalange in our big toe. The one furthest away is the distal phalange. The big toe, very much like our thumb, is missing the medial phalange. All the other toes have a proximal, medial, and distal. We have the proximal, medial, and distal, proximal, medial, and distal, proximal, medial, and distal. So as you can see, it's very, very similar in many ways in terms of the anatomical structure to the human hand and the makeup of the osteology of the human hand. So just a quick rundown. I started with a wedge shape. I very lightly blocked in a rectangular shape, and I had to make sure that it extended out beyond where the tibia and fibula would come and form this synovial joint, the ankle joint. And remember, it's a hinge joint, so it can rotate this way and it can rotate that way, to just very much like the hinges on a door that opens and closes. That represents the movement of our ankle. Then we have the talus, the calcaneus, the navicular, the cuboid, the three cuneiform bones, medial, intermediate, lateral, the 5 metatarsal bones. That's digit number 1, 2, 3, 4, and 5. And then we have the phalanges on digit 1, phalanges on digit 2, phalanges on digit 3, phalanges on digit 4, and the phalanges on digit 5. So that is the general makeup of the structure of the human foot, and it's extremely helpful to understand this simplified shape and the bones in the human foot. You don't see a lot of muscular structure covering up the bones and the simplified shape. So if you can always remember this wedge shape and have a good general understanding of the osteology of the human foot, you should always be able to draw a pretty decent foot. There is a little bit of muscle structure. There's some really important ligaments and tendons to keep in mind, but in general, most of the shape is based on the structure of the bones. So you get that down, you should be able to draw the human foot without too much difficulty, very much like the hands. What I'll do now is I will shade this in a time lapse so that you can see what it looks like when the bones of the human foot are fully shaded. And then from there we'll move on and we'll go a little bit over some of the muscle structure and ligaments and so forth of the medial side, of the medial aspect of the human foot. So here we go now with the time lapse.